So we're going to compare our initial values for the given equation and the given graph. So we're given the equation, which I'm going to do in one color. So Q of X, or P of X is the equation. And we're going to identify the initial value. And then we're going to do the same thing for the graph. So we're comparing initial values, which, if we remember from yesterday, our exponential model is y equals a times b to the x power. And we can label that a, that is our initial value. So we're going to be finding the a value of our equation and the a value of our graph. So looking at the equation, it's already given to us. So our equation is P of X equals 2 to the t power. So I'll write that as y equals 1 times 2 to the x power. So I just changed the P of t to a y, and I changed the t to an x. So our a value is equal to 1 for the equation. So identifying parts of the equation is pretty easy when we're given the equation. When we're given a graph or a table, we have to do a little bit of work before we can get our answer. So we're going to look at the graph. So for the graph, I'm going to change my color. So my a value, that's my starting value or my initial value. So looking at my graph, it starts at 400. So my a will be 400. And then to find my b value, I have to do what we did in the warm-up and do our second y value, which is 576, and divide it by our first y value, which the graph shows us is 400. So we're going to type this into the calculator, and this is going to tell us what b is equal to. So b is equal to 1.44. That's what we get when we type this into the calculator. 576 divided by 400. So my equation, y equals 400 times 1.44 to the x power. Now that I have both of my initial values, so I'm going to go and I'm going to highlight. So since we're comparing our initial values, my initial value for the graph is 400. My initial value for the equation is 1. So which one has a greater initial value? The graph or the equation? The graph, because 400 is bigger than 1. So go ahead and write that sentence in your notes for number 1. The graph has a greater initial value because 400 is greater than 1. All right, so now we're going to look at the second example. So this time we're going to compare our growth factors. So this time we're going to compare our growth factors, which that's our b value. So we'll go ahead and label our b value as the growth factor. So we're given a table and we're given an equation for example 2. So the nice thing about the equation is I can already tell what my b value is. So this is y equals a times b to the x power. So for my equation, b is equal to 1.92. So again, you don't really have to do much to identify the growth factor from an equation, but we do have to do a little bit of work from the table. So we have to take our second y value and divide it by our first y value. So our second y value is 2, our first y value is 1. So I'm going to do 2 divided by 1, which that's equal to 2. So b is equal to 2 for the table. So which one has a greater growth factor, the table or the equation? Which one's bigger, 2 or 1.92? That one's bigger? The 2 is bigger. So the table this time has a greater growth factor. Because 2 is greater than 1.92. So this time we were comparing the growth factors, and we saw that the table had the bigger growth factor because 2 is bigger than 1.92. All right, we're going to go ahead and look at the third example. So this time we're going to compare the value when x is equal to 10. So far we've done comparing the initial values for number 1. Then we compared the growth factors, which were our b values for number 2. So for number 3, we're comparing the values when x is equal to 10. So we're going to need an equation for both our graph and our table, and then we're going to plug in 10 for our x value. So let's start with our graph. So here's our starting value, and then we have to find our second y value and divide it by our first y value. So I'll pick another point about right here on the graph. So it looks like we start at 0, or actually we'll just say that's closer to 1. It's not exactly 0, but we'll say it's like close to 1. It's like really, really small. Okay, then I have to do my second y value, which is 500, divided by my first y value, which we're saying is 1. So 500 divided by 1 is 500. So my b value is 500. So I can write the equation y equals 1 times 500 to the x power. And I said once we have the equation, we're going to let x equal 10. So in the calculator, I'm going to type in 1 times 500 to the 10th power. So I'm going to replace that exponent with a 10, and I'm going to open up a Desmos graphing calculator. I'm going to type that in. Y equals 1 times 500 to the 10th power. So it looks like we have 9.77. So y is equal to 9.77. So that's one of the things that we're going to be comparing. We're also going to look at this table, and we're going to do the same thing. So we're going to find our starting value, which our starting value looks to be at 300. So A is equal to 300. And then I need to do my second y value, which is 390, divided by my first y value, which is 300. I just got those numbers from the table. I did this number divided by this number, and that gives me 1.3. So my b is equal to 1.3, which means I can write my equation, y equals 300 times 1.3 to the x power. And we want to know what is the value when x is equal to 10. So instead of x, we're going to write a 10 in there. And then I'm going to open up a Desmos graphing calculator, and I'm going to type that in. y equals 300 times 1.3 to the 10th power. And I get 4,135. Y equals 4,135.75. So this is the answer that I get when I plug it into Desmos. 4,135.75. So ultimately, which one has the greater value when x is equal to 10? The graph or the table? The table, because 4,000 is bigger than the 9.77 that we got for the graph. So the table has a greater value when x is equal to 10 because 4,000 is greater than 9.77. All right, so for number 4, notice that we're comparing 3 different brands of a computer. So we have brand 1, which is given by the equation, brand 2, which is given by the table, and brand 3, which is given by the graph. And we want to compare the cost of the computers. The initial cost of each computer. So we'll figure out which brand we want to buy based on which one is the cheapest. Okay, so starting with our equation, so our A value is our starting value, our initial value. So for the equation, it's very easy. Our A value is 485, our first number of our equation, which means the computer for brand 1 is going to be $485. Now, looking at brand 2, we don't have an initial value because we're not given the time at 0 months. So 0 months would be when we initially bought it. So for the table, we actually have to do our second y value divided by our first, and then we're going to go backwards to figure out what our initial value is. So we're going to do 401.58 divided by 414. We'll type that into the calculator. So that gets us 0.97. So I'm going to take my 414 and I'm going to divide it by 0.97. And then I'm going to fill in the rest of my table. So after 1 month, the value was actually $427. And I'm going to do 427 divided by 0.97. So after 0 months, brand 2 costs $440. So for brand 2, our initial cost of the computer is $440. So far, brand 1 is more expensive than brand 2. So now we'll just compare our A values for the graph. We'll figure out if brand 3 is cheaper. So to find the initial value on a graph, you look for the very starting point. That's our y-intercept. So for brand 3, our starting value is 400. So which brand should we buy our computer from? Brand 1, brand 2, or brand 3? Shh. Which brand is the cheapest? 400, 440, or 485? Which one is the cheapest? Huh? Brand 3, which is costing us $400. We want to go with brand 3 because 400 is the cheapest brand.